special products. This is just like the stuff we've been doing. We're multiplying polynomials still. There's just a couple special circumstances of polynomials where if you can remember the special circumstances, you actually save yourself work. If you don't remember anything from 7-8, it doesn't matter. You're fine. You can still do everything from 7-7. It'll work. But if you remember the special circumstances, you're saving yourself time. So the first one we're going to look at is the square of a sum. The square of a sum is two numbers or two variables or whatever, and we're squaring those. And the easy pattern to remember, and I'll tell you this, the way they write it out is silly. When we have a square of a sum, we're going to square the first, we're going to double their product. Pay no attention to that page turning. And we're going to square the last. And that's it. It's really that simple. So here's what I mean by that. So if we take, for example, if we square 3x, we get, anybody? Live studio audience, we get 9x squared. If we double their product, and by that I mean product means multiply, their product, the product of 5 and 3x is 15x. Double 15x and you get, hey. And then square the last. What's 5 squared? And that's it. So if we have a square of a sum, you don't have to do FOIL. You don't have to do the Punnett square method. These, if you can remember that this is a special circumstance, we can do these very, very quickly. So for example, if we look at 1a, square the first, double their product, square the last. Okay? And that's it. So if it's a square of a sum, so I can remember the rules, so I can do that problem very quickly. You go ahead and pause the video right here. Try 1b on your own, and we'll check that later. Okay? We'll check that in class. All right, you've unpaused. Hopefully you got the right answer. Like I said, we'll check it in class because we have a live studio audience. Don't want to give any spoilers away. All right, same exact pattern exists for, that's what I want, not everybody, sorry. Same exact pattern exists if we have the difference, the square of a difference. So we'll look at that. Let's pull this up here because the same exact rules apply. You square the first, you double their product, and then you square the last. The only thing you have to remember is that we have a negative sign in here, so their product is going to be negative. So if we look at the example that was given, 2x minus 5y, we square the first, that's 4x squared. Double their product is 2 times negative 5, which is negative 10, and then we double that, so that's how we get our negative 20, and then xy. And then square the last, negative times negative is a positive. Okay, so that's the other special case. It's the square of a difference. So sum of squares or difference of squares, we do the same thing, or square of a difference, excuse me. Square the first, double the product, square the last. If we take a look at 2a, we square the first there, and we get 36p squared. We double their product. Well, their product is negative 6p. Double that, and it's negative 12p. And then you square the last term, and you get 1. And that's it. Just because I remembered the special circumstance, I'm able to do the problem very, very quickly. You go ahead and pause the video right here. Try 2b on your own, and we'll go over that one in class also. Okay, try 2b on your own, and we'll go over that one in class. The product of the square of a sum, or the square of a difference, is called a perfect square trinomial. It's a trinomial that we can take the square root of. It's going to show up sometimes in word problems, for example, like the edge. Each edge of a cube of aluminum is 4 centimeters less than the edge of a cube of copper. Write an equation to model the surface area of the aluminum cube. C is the length of each edge of the cube of copper. So this is the copper cube right here. C minus 4 is the length of each edge of the aluminum one. Surface area for a cube, they give us the formula. It's just 6 times the side squared. So what we do is we have 6 times C minus 4 squared. the c minus 4 squared, this is where we're going to apply our square of a difference. So we square the first, so that's c squared. We double their product, so that's our negative 8c. And then we square the last, and we get 16. And then that's the answer. Okay, really no big deal. Here is a problem that I want you to try. Alano has a garden that is g feet long and g feet wide. He wants to add 3 feet to the length and the width. Show how the new area of the garden can be modeled by the square of a binomial, and then find the square. So if we draw this garden, and it's g by g, and what Alano wants to do is make it longer, 3 feet this way and 3 feet this way. So we're trying to make it into a garden that looks more like this. We have g plus 3 squared. So if we apply the square of this, the rules here for square of a sum, we square the first, so we get what? G squared. Double their product. What's 3 times g? 3g, doubled. 6g. And then square the last. 9. And that's it. Okay? That's it. The last kind of special case is when we have a product of a sum and difference. Okay, and there's a word for this that we'll learn later on in math called conjugate. But really, we have a plus b times a minus b. So if these are the same exact numbers, terms, but one is a plus and one is a minus, what we're able to do is you square the first minus square the last. And the reason that works out is really simple. It's because if we were to multiply right here, 2x squared times 2x squared gives me my 4x to the fourth. If we're doing FOIL, okay? When I do the outer, I get negative 6x squared. When I do the inner, I get positive 6x squared. Those add up to 0, so I don't need to include them as part of my expression, okay? Then all I have left to do is square the last, which is minus 9, okay? So when the terms, and this is really important, this isn't just like works all the time kind of stuff. It has to be this and this are the exact same. This and this are the exact same, and then one is a plus and one's a minus. And when that happens, I square the first, minus, square the second. It works every time. So if we look at these two examples, 4a, square the first. What's 3n squared? 9n squared. 3n squared is 9n squared, minus 2 squared. And that's it. If we look at 4b, what's 4c squared? 16c squared minus 7d squared. 49d squared. And that's it. Those are special case polynomials where we're multiplying. There's some practice problems there for you, 1 through 7 to try. We'll go over those in class. See you next time. Bye.